on to the last problem. So this problem involves a force, time, and speed. And so that suggests to me that this is going to be an impulse problem. So let's see a momentum impulse problem. So let's see what we know. So the momentum impulse problem is m1 v1 plus the integral of f dt from t1 to t2 will equal m2 v2. And in this case, the mass is not changing, so the mass is constant. So we don't have to keep track of mass 1 and mass 2. If you have a propulsion problem, the mass is decreasing and you need to keep track of it. Okay, so let's see what we have here. We know the force, or we can get the force from a free body diagram, and it's a function of time, at least the tension is. We got to figure out what the force on the crate is. And it starts from rest, I think, yes, starting from rest, so that's 0, and it's wanting to know what's the velocity. Let's see, what's the velocity at t equals 4 seconds, so that's at 4 seconds. Okay, it mentions that there's the kinetic and static coefficient of frictions are 0.3 and 0.25, which suggests for a little while it's not going to move, and then after that it will start to move. Okay, so I'm going to start this with a free body diagram, so I'm going to circle that there. Okay, and let's draw everything that's in that little circle there. So I've got the crate, this, I've cut through, well, let me draw everything in there. So I cut through here, here, and here. And if you look carefully, let me highlight the rope. That's all the same rope. So all three of those will be T, T, and T. There's the weight of the crate, 500 pounds. There is the normal. And then there is the friction force, which may or may not be mu times n. So at first, when it's low, it won't be. Okay, so let's do this. So sum, and this will equal ma. Okay, so we'll do sum Fy equals 0 in the up direction. So we got minus 500 plus n equals 0. So the normal force is equal to the weight, 500 pounds. And so the static coefficient of friction, mu static, is 0.3. So up until the force is 0.3 times n, okay, which is 50 times 150 pounds. Up until 150 pounds, it won't move. And after it hits 150 pounds on the crate, then the coefficient of friction will drop down to 0.25. And 0.25 times 500 is 125 pounds. So the first thing we're going to have to do is find out when the time where the block starts to slide. So when the total force, which is 3, so we'll just do, let's start this over. So we'll do sum Fx equals ma, which equals 0 because it's not moving yet. So we get minus the friction force plus 3t equals 0. The friction force will equal 3t until it's moving. And it will start moving when the friction force equals 150 pounds. So what we need to figure out is when t equals 50 pounds. So let's look at this equation here, this graph. We're given it starts at 30, and then it gets up to 60 at 2 seconds. So the slope is 15 to 1, right? Because 15 times 2 is 30, 30 plus 30 is 60. So the equation for this line is 30 plus 15t. And so when does that equal 50 pounds? Solve for t. So t equals 20 over 15, which is 1 1/3 seconds. So let's redraw the free body diagram starting at t equals 4/3 seconds. So what we have the block here. It's got a weight of 500. It's got a normal, which will equal 500. And then after t equals 4/3 seconds, it's sliding. And so the friction force will be 0.25 times n, which is 125. And you have pulling 3t, and that will equal ma. So now we're prepared to use our impulse momentum equation. So we know the original impulse momentum was 0, plus the impulse, which is the integral of force dt, starting at 4/3 seconds when it begins to slide, up until 4 seconds where we want to know the velocity, will equal the mass times the velocity in question, velocity 2. But if you look at the equation, if you look at the plot for the tension, it's changing from at 2 seconds. It's linear and then it's constant. And so what we're going to have to do is break this integral from 4/3 to 2 seconds f dt, and then the integral from 2 to 4 f dt equals mv2. And so really, this impulse momentum equation, there's supposed to be a sum in there. So it's the sum of all the forces, and it's a vector equation. So we're just going to take the x components of everything, okay? And there's only the x forces. So let's do the integral. 0. Let's make a line here. The integral from 4/3 to 2 of all the x forces. So you have the friction of minus 125 plus 3 times the tension. And the tension force was, for the linear part, 30 plus 15t. Okay? And so we'll do that, dt, plus the integral from 2 to 4 seconds. The total force is minus 125 for the friction, plus 3 times the tension, which will be 60, so that'll be 180 total dt, and that will all equal mv2. So I'm going to do a little bit of algebra and come right back. So this came out to be the integral from 4/3 to 2 of minus 35 plus 45t dt, plus integral from 2 to 4 of just 55 dt equals mv2. And doing those integrals, that'll be minus 35t plus 1/2 45t squared plus 55t. This from 2 to 4, and this one from 4/3 to 2. So I'm going to plug in those numbers and be right back. So that came out to minus 23.33 plus 50 plus 110, which all comes out to 136.7 equals mv2. And the mass was 500 pounds divided by g, so 136.7 times 32.2 over 500 equals v2, and we get that v2 equals 8.80 feet per second. I really hope that's right. And yes, it is.